Hello, my name is Zach Johnson. I'm a student at Iowa State University, but I work with Spec over the summer. Yeah, and so today we're going to be going over some exercises, a little exercise sheet I wrote up that are going to highlight some of the ideas that we're seeing in the introductory R training. So first things first, I set up the data frame here. It's just an arbitrary random data set. Don't worry about the syntax here. I just like it better when I can have nice, easy data, and it's formatted terribly, but it's fine because we're just going to run that, and now we have a data frame here. So let's see. Actually going to do that. Okay. So then for the first exercise, we're looking at indexing. Indexing is really important when we're using R because it helps us get the elements of vectors that we need and helps us pick out particular ones with logical functions and things like that. So, picking out the numbers we need. So let's just so what we're going to do is I'm going to save my name. So I have if we look at the data set here, we got Alex, Benjamin, Megan, John, Git. These names might seem familiar to you, but I'm going to pick out mine because it's my vector. So I'm going to call it Zach. We're going to assign that. So the data frame is called lab. We see that here. I named it lab. So lab, and then we're going to index it. We're going to leave the row, the row part empty and do the column. And because mine is the 1, 2, 3, 4, 5, 6, 7, seventh over, 7. And then we have a new, if we look over in our global environment, we have a new object called Zach there. And then we can access elements of Zach by going, we can go 1. And so we see 7 as the first element of Zach, or we could do Zach 1 through 4. You might recognize the colon there as a through, so this is equal to, and we can see it in the console here, 1 through 4. It's equal to 1, 2, 3, 4. It's just the series of numbers, pretty much. Yeah, so then if we go back to the directions, we move on. Yes, math. I love math. Let's do math. So we already have the first one up here, the first element. So we're going to save that as x. And I'm actually going to pull this over so I can look at the thing while I do it. So we're going to add 2. So we're going to save the first element as x. And we're going to add 2 to x and save it as x1. So, and we can perform, if we recall, we can perform arithmetic operators on objects. So we can add 2 to x. Oh, I didn't save it as x. So save it as x. Then we have x is 7 because that's the first element of Zach. Then we add 2 to that element and then save it as x1. So then we see x1 is going to show up, and 7 plus 2 is 9. So 9 is going to be the assigned value of x1. And that's a really important concept, that assigned value concept. And then x2, we are going to multiply x1 by 3. So we use the asterisk for multiplication. So multiplying it by 3, we get 27. And then we're going to subtract 6 and save that to x3. We're going to subtract 6 from x2, the one we just made. So x2 minus 6, that one's pretty straightforward. Get 21. And then we're going to take x4 will then be x3 divided by 3. And so according to my idea here, we should get the same number as we start with. x4 should be equal to x. And we can check this. I mean, we could just look in the global environment, but if we're dealing with vectors that have thousands of numbers, that's going to be hard. So if we wanted to check that without that, we would use the double equal sign, which is to say strictly equal to. That's what the double equal sign means. You'll maybe recall that from the logical operators part. So this is kind of using an action. And so yeah, that's going to return true because x is equal to x4. Yeah. So statistics is fun. The better side of math, if you ask me, but that's just me. So this is kind of going to be a little hands-on use of functions. So we talk about functions, and functions are really useful for us because we can do really complicated operations. Well, taking the mean isn't that complicated, but it's just a simple example. We can do some really complex things and not have to do all of the hard work, which is pretty good if you ask me. So we're going to take the mean of Zach, which is a vector, if we recall, because I took the vector from the data set we had before with all these vectors. Yeah, so we can get the mean. We can do things like take the median of Zach. We can do things like find the standard deviation of Zach. Yeah. So, I don't memorize these. So like honestly, I don't memorize these, and that's because if I tried to, with the thousands of packages that exist with R, that would be impossible. So what's really important is that we know how to read documentation, so we can do this. So if you use the question mark and then type the function name, it's going to pull up the R documentation, which is really helpful for us because it's going to tell you what the arguments are, that is what parameters we're putting into the function, what numbers that function can take. It gives a little description, gives some examples, gives us some references to some sweet books that we're probably never going to read. So learning how to read documentation is a really important skill because it allows you to learn really any package and learn any function and then apply whatever other people have already done the hard work on to whatever you're working on. So, but so it's a little hands-on thing for functions. So then we're going to move on. So before we use because it's important to know the indexing part with the square brackets, and I guess it's also important to note that we can take any row value from this too. So we don't have to just take the column. We can go to find the first element. We could just do that. Oh wait, why didn't that work? Let's get rid of that. So we can find the first element there by using the first row and then of the seventh column. The first element of the seventh column is really what that's saying. But we can also access columns with what we call a $ notation. So we have the data set lab, and we can see that 7 by 20 data set. And we can, if we hit the $, we can then access individual columns of that data set. So we can just do the Zach vector within that data set. We can also, and this makes it a lot easier because then I don't have to memorize what element mine is, right? And I can just do it by the name. So this is really a lot more useful when we're looking to pull different columns. We can pull John's column. But it's also important to use that index notation, and it's important to know what that is for other uses later on. So then finally, we're going to talk about reading data because that's sort of the last sort of foundational thing that's really important, or not the last one, but the last one I'm working on here. So reading data is really important. We use the read.csv function for that. Generally, if the data type is CSV, which it oftentimes is, and if anything, it's a useful example to use. So I'm using a randomized thing to make this data. So, but I saved a different version of the randomized data in my system here. And so how we access this is we look at this and we go, we type out what we want it to be called. So let's say we want to call it lab again, or we'll call it lab 1. So we assign that and we use the read.csv function. And then within this, we're going to need to type out a a file path. And so a file path is really, using Finder, if you have a Mac or whatever Windows uses, like a file, wherever your files are, you can there's a path that's associated here. And on most machines, you're going to have a user sort of main path, and mine is called Zach Johnson. Yours is probably not called that, unless you are Zach Johnson. And so for Macs at least, and I think I know the notation for Windows, and I'll show that here. So for Macs, the home directory or the home user directory, what you do when you sign into your computer, is that, where did that go? The squiggly line and then the backslash. And then for every step into this, so as we see here, we have R for political science, then I have my files here, the poli-sci 490 files, and then within that, intro to R, within that, it's sort of a nesting doll type, if we can think about it like a box within a box within a box. So what we're doing when we're typing out this this file path is typing out the elements in the box, and getting more specific every time we do it. So so let's actually read in a different data set that I just have on my computer. Let's just call it data, which is a bad data set name, by the way, but whatever. So let's go into the data file, or into the data folder within this, and we're going to get the class data here. Yeah. So what that is it's Zach Johnson, which is my home directory, or the user directory, which is done with this, the squiggly line and the backslash. And then here we can hit tab if it stops going over. Oh my goodness. Okay, I think I know where I'm going from here. I'm gonna pull this over. This is being annoying. It's fine. We can hit tab, and it's actually going to pull up everything that's within that user directory. So I know I wanted to go to, let's see, where was it? R for political science. Then I can hit tab again, and it's going to show me everything that's within that. So we're going to go to poli-sci 498 files. Then within that, we're going to go to the data. And then within that, we can go to the class.csv. And so now that we have this, again, nesting doll type file path going on here, we can run that. And there we go. We have a data set. And this is actually the similar sort of randomized data that I used for my class that I'm teaching this fall. So yeah. So that's kind of it. So yeah, go team, go R.